Okay, welcome back to math class. Yesterday we talked about factoring polynomials with 4 or more terms. Now all of the ones that we did yesterday were like this one where, for example, if I pull out 4r here, I'm left with q plus 1. Here I pull out a 3, I'm left with q plus 2, q plus 2. So all of the ones we did yesterday ended with what's inside the parentheses being exactly the same, so that I could easily pull these guys out into two separate binomials being multiplied together. Today we're going to talk about what happens if these two aren't exactly the same. And we're going to call this factoring by grouping with the additive inverse. And I'll show you what that means. So we're going to take a problem, c minus 2cd plus 8d minus 4. Now we're going to do the same thing that we did yesterday. Our step 1, group terms. Now here it looks like they're already pretty well grouped because I've got my c's together, and both 8d and negative 4 can be divided by 4. So that step's already done. Then step 2 is going to be factoring our greatest common factors out, just like before. So here I'm going to take out a c and get c times negative 2d. C divided by c is 1, minus 2cd divided by c is going to be minus 2d. Right, and then over here, I'm going to take out a 4, so then I'm going to get 2d minus 1. All right, so looking at this, what's inside the parentheses is not the same, so we can't just combine it like we did before, because 1 minus 2d isn't exactly the same as 2d minus 1. So before we can move forward, we have to make sure that this, what's inside these parentheses, matches what's inside these parentheses. What I'm going to do is I'm going to say, well, I know that 2d minus 1 is the same as saying negative 1 times negative 2d plus 1, right? I've just pulled a negative 1 out of there, divided the whole thing by negative 1. So I can go ahead and replace this in this equation with this one. So this becomes minus 4, right? 4 times negative 1 times negative 2d plus 1. So now I'm one step closer to being at this equation, right? Because this is a positive 1 and a negative 2d. Still not exactly right. Minus 4 times this. But I know, based on my additive inverse property that we learned way back in chapter 1, that negative 2d plus 1 is the same as saying positive 1 minus 2d. All I did was switch them because they're just being added together, so it doesn't matter what order we add them in. So now I'm going to replace this in our equation with this one. So I'm going to get c times 1 minus 2d minus 4 times 1 minus 2d. Now, what's inside the parentheses matches, so now I can combine the outsides. C minus 4, just like we have been this whole time, times 1 minus 2d. So there's a couple extra steps, but all we have to do is use what we already know to rewrite what's in these parentheses to make it match. Okay, I have one other thing in this lesson. What we've been doing so far is grouping, factoring, doing the distributive property, but now we're going to actually talk about what it means to solve an equation using what we know about factoring. And what we're going to use to solve equations is something called the zero product property. This is another one of those properties we learned in chapter 1, but I know it's been a long time, so we'll talk about it. You know what it is, because basically the zero property is anything times 0 equals 0, right? Even if I have 0 times 2x plus 5, that still equals 0. Anything times 0 is itself. So if I have two monomials or binomials or any kind of polynomial multiplied by itself, or multiplied by each other, 3n times n plus 2, and I've told you that this equals 0, then what I know is that one of these, or both of these, must equal 0, right? Because for it to equal 0, one of these has to also equal 0, at least one. So to find the solution to this equation, I'm going to set each piece equal to 0 and then solve. So I'm going to put 3n equals 0, and I'm going to put m, so either 3n equals 0 or m plus 2 equals 0. One of them has to in order for this equation to be true. So if 3n equals 0, then n has to equal 0, right? Because we divide by 3, 0 divided by 3 is still 0. Or, so either n equals 0 or n plus 2 equals 0, so minus 2, n equals negative 2. And that's our answer. We don't know which one it is. Either n equals 0 or n equals negative 2, or both.